Hello and welcome back to Prince Exam Boost, your one-stop shop for all science-related topics. We are in the concluding part of set theory. So in this video, which is way more detailed, we are going to handle all calculations related to set down to set notations itself. So please remember to like this video, subscribe, share, and comment. All right, it helps improve our audience and increase our reach. So I'm looking forward to that. All right, so let's step right into the questions related to cardinality. So we have a question on the screen. We can begin by listing out the sets in the sample space. It says that X is the Z symbol indicates integers, and integers simply means whole numbers. Real number system is much more larger than that and includes decimals. So for some questions, they will be specific on the range of values they are expecting. And you have values from 0 all the way to 19. Now, many students would understand this topic and yet fail it because of attention to details. So if you see what was given to you in bracket, the beginning was 0 less than or equal to, and that's why my 0 was included. But the last part says less than 20. Many will go into including 20, and that will be the first mistake. And one thing I hate about this topic is if you make mistake with one digit, you mess the whole thing up. Nothing makes sense anymore. So please pay close attention to details. And then comes the first set, A. We've also been told that A include integers as well, and just the even numbers. So what are the even numbers we have? 0 is an even number. 16, 18. Now there is something we are doing. You see the sets A down to the rest. The question has already indicated that A, B, and C are subsets of the universal set or the sample space. So what that means is that they could have given me boundaries for S. They don't need to give me boundaries anymore for the rest, because whatever I'm listing should not exceed values in the universal set. So in this case, since I know that A and B and C are subsets of S, while I'm listing the even numbers, by default, I stop at 18. I cannot add 20 because the universal set from which A was brought out does not have 20. So you have to stick to the rules. While the element B include the multiples of 3. Of course, 0 is the first multiple of 3 when you do 3 times 0, and then it comes 3, 6. We stop at 18, of course. 21 does not belong to that universal set. And then last but not the least, we go to the third element, the third set rather, prime numbers. So that means, again, definitely the prime numbers within the sample space. So what are the prime numbers here? All right. So we have these elements listed already. First question says A complement intersect B complement. So whenever you have questions like that, you have to figure out what the complements of A was. We already have the universal set on your screen. So what would be the elements missing in A? Let's go straight to listing out all the complements of A, so we can intersect it with the complements of C. So A complement will be, since there was 0, there was no 1, there was no 3. These are the complements of A. So we also need to pick out the complements of B. Remember, complement means you're comparing it with the sample space. So looking through your sample space, if B has 0, there is no 1, no 2, then we have 3, there's no 4, no 5, 4, 5, 7, 8, and 17. Lastly, 19. Good. Now we have the element of A complement, and we also have the element of B complement. So we can now get the intersect between A complement and C complement. If you are dealing with a theory question, it's important that you list every step of the way, every work you're doing. So we now have to look for intersect means common elements, right? So These two have 1, they both have 5, they both have 7, they both have 11, 13, and they both have 17 and 19. Good. So we have 1, we have 5, we have 7, we have 11, 13, 17, and 19. So this becomes our answer for A complement intersect B complement. We are going to take 2 more examples and then we'll move on to the next. As we know clearly, when we have a question like this, we need to first figure out what A union C is. When we have that set, we can now look for what's missing between that set and the universal. So let's get right away. A union C would be joining A and C without repeating any element twice. We have 0. There is 2 and 2 here, but I just need to take 1 like I said. We have 3, 4, 5, 6, 7, 8. No 9 on both sides, but they have 10, 18, and 19. So it's A union C. Now that we have it, that's a whole lot. We can now figure out what the complement of this set is. That means comparing this set with the universal. So there was 0, but there is no 1, which we have in the universal. So that becomes 1, 8, no 9, 14, no 15, 16, 17, 18, 19, and that's all. So A union C complement becomes the values 1, 9, and 15. Over to the last example in this section. Is A complement intersect B union C? Just as it is listed. I first need to know what A complement is. Then I need to know what B union C is. And at last I can look for the common element between them. So let's get right away. A complement as done before, the values missing in A, 1, 3, 5. These are the complements of A. Then B union C is the joining of these two without repeating any element, and 19. Good. Now we've listed everything in B union C by joining B and C together. We can now look for the common elements between A complement and B union C. This becomes, let's see. So A complement, they both have 3. It's clear. They both have 5. They both have 7. They both have 9. They both have 11. They both have no 12. They both have 13. They both have 15. They both have 17. And they both have 19. So this becomes the intersect of A complement and B union C. So that's it for this section of set. You do well to solve many more examples until you've mastered isolating these elements and finding the relationships between them. Now we are moving over to Venn diagrams. We will start with the 2-way Venn diagram and then we'll go into the 3-way Venn diagram. Now over to Venn diagrams. Venn, as we know, is just a graphical way of representing sets. It kind of gives us a pictorial view of the elements that are common between different sets in a universal set. We have 2 major ones usually employed. In this video, we will go even deeper than that, but still that foundation is necessary for your performance in higher examples. So how does a 2-way Venn diagram look? It looks like this. This square can represent the universal set. Now, if we had a subset extracted from it called A, this first circle represents A. And the second set extracted from it called B. Just like we solved in the previous examples, you've seen that sometimes elements in A could also be in B. And that's where this region is, that's what this middle region is for. So a 2-man Venn diagram has 4 major compartments. We have the region in this A only. We have the region that have both A and B. We have the region that have B only. And then we have the region outside all of them combined, outside two of them. Okay? So, this first region is called A only. So, the first region is called A only. This second one is called A intersect B. So this is where the common element between them is kept or are kept. Then this third region is for B only. And the last region are for the people that did not take part in A or B. So usually we kind of call them the complement of A union B. If you combine A and B together, that's what we call A union B. Then any region outside that becomes the complement of A union B. That means what they don't have. So A union B complement. Now what you need to know is that the mathematics is that to get universal set, you need to add A only with B only. You also add it with the A intersect B and add it to the A union B complement. 4 of them added together is equal to the universal set. The only place you might have problem is you hardly see a question that gives you only A. You might be told that in a class of 50 students, 30, 30 offer geography, 25 offer physics, 10 does not offer any of those two. How many offer both? Like, you see what I just said? I just said 10 offer geography, this offer physics. I did not specify only geography or only physics. So how do I get only the first and only the second without having the digits of the intersect within them? So what you must know is that your keynote is that to get A only, you will always do the total you find in A minus, let me call the people in their intersect, let me call them X, okay? You will always do A minus X. If you want to get B only, you will always do B minus X. Very important. So only in cases where the values of each was given, that's when you don't do this. But if you are just giving a generic statement without the word alone or only, you must subtract so that you don't have duplicates in the document. So because of that, it means that if I want to get my universal set, I can always do A minus X added to B minus X added to the intersect itself, which is X, and then added to the ones outside X, which is the A union B complement. So now this formula becomes the most important formula in this topic. Oftentimes, you will not be giving people that didn't do both. For example, I could have just told you that in a class, they offer either geography or physics, nobody outside. And when you're solving, your exclusion becomes 0. Those outside, the both of them become 0. So let's see a typical example and see how to manipulate that. An example is on your screen. Okay, so in your question, as seen on the screen, the total number of students will represent the universal set. So the U is equal to 50. We have some set of students who wear wristwatches and those who wear earrings. We are looking for those who did both. Whenever you're solving question on Venn diagram, the middle is the most important. You must always start there. So since we don't know how many who did both, we will start by putting that place as X. Now then go to the question. Wristwatches are 30 students. And they didn't say 30 students wear wristwatches only. I need only here. So since that's not given, I will write 30 minus X. While 35 wear earrings. They also did not add only. So I have to subtract X to get the ones that did only earrings, that have only earrings. And then 10 students did not or do not wear any of those two. So 10 students are outside. Nice. This is why we love Venn diagram. Venn diagram makes everything visual for you, so you can clearly see the addition looking at you. Our total becomes those in W only, 30 minus X, added with those in E only. Oh, this is 35, not 30, please. So that's 35 minus X, added with those that did both, which is X, added with those outside, which is 10. And that gives us 50 equals, opening the bracket, 30 minus X plus 35 minus X plus 10. And this gives us 30, 65, 75. We have 75 minus X, that's minus 2. Minus 2 plus 1 becomes minus X. This is where we are. Now we finalize, and our X becomes 75 minus 50. That means 25 students among them are putting on both wristwatches and earrings. When you've been able to solve those who did both, questions can now ask you to solve those who have only one of those pairs. Calculate the number of students which have only one of those pairs. So if I want to solve that, to get the number that have only one pair, it means I will add the W only and the E only. That's all. So that gives us W only, which was 30 minus 25, added to E only, which is 35 minus 25. This becomes 5 plus 10. So the people that have both like that are in total 15. Gives us 15. Okay? That's how easy it is to solve two-man Venn diagram. I'm going to come back with a little bit of a tricky example, but for the sake of our video, in order to keep our video short, let me go straight into understanding the set notation now for every part of this two-man diagram. All right, so here we have an empty Venn diagram. Outside is the universal. This is the first set A, and this is the second set B. So let's look here. If I was to use a shaded line for the regions that have B in it, and then I use this other diagonal for the regions that have A in it, good. You will observe something, that the people that have crosses like this and like this, crosses, the place where this happened was in the intersect zone. So it means that this portion is going to be called A intersect B. Right? Now we can see now that the region that only have this diagonal is for the A only. A only. So how do I represent that in set notation? A only. This one. See, what I always tell them is, if you're looking for A only, it means use A to intersect everything outside B. Remember, B does not have this portion. So it means that this portion is the intersect between A and the B complement. So people outside B are called B complement. So this becomes A intersect B complement. Very nice. Why this other region that only had B only? The region with B only. It will also mean what? It means that there is no A there, so that's A complement intersecting B. So this becomes B intersect A complement. I cannot tell my students, it's easy to remember. Just tell yourself A only will be A intersecting the complement of the others. B only will mean B intersecting the complement of others. Simple. while the region that was completely empty, that I didn't shade, the unshaded part, it's now the people outside A and B combined. So that means this outside is for the complement of A union B. So this is A union B complement. Take note of this notation because there is something we'll come back to. There are two ways I could have written this one. But I don't want to confuse the video right now. It's even good you remember one notation first rather than try to cram two different notations for one portion. It's not necessary, right? But we'll come back to something like that. So that's it for a two-way Venn diagram. Now let's move over to a three-way Venn diagram, after which we can now solve some complex examples. So here with me we have a three-way Venn diagram, and the square once more, the rectangular shape represents the universal set, and the A, B, C are the three subsets in that set. And we know that some elements in A could be in B, and that's the region covered by A and B, some regions between A and C, some regions between B and C, and then there is this central region which is the intersection of all three sets. Now once more, we are going to go into their notations much later, but for now what you need to first master is, when solving three-way Venn diagram, the central point to begin is the intersection of all three. So you must first look out for the intersection of all three in the question, after which you go from in and you spread outwards, meaning from intersection of all three you start filling in the intersection of two only. Now this should not be confused. This region is A only, this is B only, this is C only, this is A intersect C only, A intersect B only, B intersect C only, and here is A intersect B intersect C. Why am I emphasizing on this word only? It is because in a question you are hardly going to have that given. Sometimes you will be given, but what you are more likely to meet, the usual convention would be telling you, oh, the total in A is 50. That's not A only. Or the people who offered A and B are 32. That's not A and B only. So how do you always get the only when you have the generic one given? Just like we did for the two-way Venn diagram. To get A and B only, you will use the value given to you from A and B. You will subtract X. You subtract the intersection of all three. To get B and C only, you will use the value of B and C, also minus it from the intersection of all three in similar case. So studying the equation on your screen, the total students in this question are 40, meaning the universal set takes the value of 40. The clubs in the school are chess club, football club, and basketball club. So let's change these letters to suit the question. We have chess club, we have football club, and then we have basketball club. Question says that 20 students are part of the chess club. Now you see that they didn't say chess club only. So because of that, in the place of chess, I'll put 20 outside. I'll just put C equals 20, but I will not put it inside the sphere yet, because this is for chess only. So just keep it outside. And then it also says 15 students for football club. So outside the square, F is 15. And then 16 students are part of basketball. So basketball is 16. Good. Okay, then it went ahead to give us the values of those in two clubs. 3 members are chess and basketball. So C intersect B, 3. 6 are members of chess and football, are 6. 5 are members of basketball and football, was 5. Now I see what I'm doing. I'm keeping them outside rather than bringing them in. Why? Because these values are not the values of their only. Okay, that word only. So which means some people who are in this chess and basketball, some could also be in all three clubs. So it's not ideal that we put those values because only was not indicated. So we are going to piece out their values for only. Now let's check out for all three. One person was not a member of any club. So outside all three, we have the single student who didn't take part in any club. So which means what we now have to do in the question, all three is not there. We are not giving all three. So B intersect C intersect F is actually missing. So that is where we will start. So we'll start filling in our Venn diagram. We start here with X. Having done that, let's start looking for, let's start filling in the values of only now. Chess and football was given as 6, but since it is not only, we are going to write 6 minus X. Chess and basketball was 3. Since they didn't indicate only, we are going to write 3 minus X. Football and basketball was given as 5, and since they didn't say only as well, we are going to say 5 minus X. As far as it was not written only, you must do this. But if it had said 5 students did football and basketball only, I would have written 5 without subtracting anything. Now that we have that, we can now go for C only. To get the number for C only, the total C was 20, and we have to remove the people here, and those here to be able to get C only. So just the same way for the two ways the Venn diagram we did the A minus the intersect, that is also what we're about to do now. We'll do C minus this, minus this, minus this. So let's go. C was given as 20. We'll now do minus the first one, 6 minus X, subtracted from the second one, X, subtracted from the third one, 3 minus X. Now observe that when I was about to write this minus this, I enclosed the figure there in bracket. If you do not enclose it in bracket, it's going to later affect your calculations, because the signs that would have changed when the bracket is opened will not be changed, and then you have an error reading. So moving on, let's open our bracket neatly. This is 20. Minus and 6 comes out minus 6. Minus with minus S comes out plus X. We repeat the same. This is minus into 3, minus 3, minus into minus X, plus X. At the end of the day, we have 20 minus 6, which is 14. 14 minus 3, which is 11. For the figures, we have 11. And then minus X plus S cancels out, leaving me with plus X. So everything for that part is 11 plus X. I can now put it here in bracket, 11 plus X. Also, we move for B only. B only. For B only, also, we look out for the total B that was given as 16. We are going to subtract it from any other person you're seeing in the circle containing B. We have 3 minus X, we have X, we have 5 minus X. We are subtracting all of them. So 3 minus X, X, and then 5 minus X. So once it's opened up neat and nice, we'll have 16 minus 3 plus X minus 5 plus X. This is going to give us 8 plus X. So for this second person, this comes out 8 plus X. I will repeat the case for the last one, which is my F only. Now, remember, as I always say, they have their set notations, all right? But let's not bore ourselves with that when we need to do calculations on figures. Immediately after this, we will learn all the set notation for every section, because those questions come out a lot. So F only is 15. We'll subtract everybody you see in the circle for F. We have 6 minus X, we have X, and we have 5 minus X. So let's go. And if you neatly open that, this is going to come out as 4 plus X. So here comes out 4 plus X. Now that I have all the section I need, I can erase all this, because I will be able to find my combination of all three now. This then means my universal set 40 will be equal to the addition of every single section here. They are singles. 11 plus X, 4 plus X, 8 plus X. Now go to the doubles. 6 minus X, 5 minus x, 3 minus x, and then to the last guy in here, x itself, plus the one outside, never forget. If nobody was outside, we'll put 0. So let's solve. Opening up the bracket, 40 becomes equal to 11 plus x plus 4 plus x plus 8 plus x plus 6 minus x plus 5 minus x plus 3 minus x plus 1. So 40 is equal to, solving it, 11, 15, 23, 29, 34, 37, 38. This gives us 38. Now x, 2x, 3x, 2x, 1x, 0x plus x. So this is plus x. So now we can collect like terms, right? X becomes 40 minus 38. So therefore, x equals 2. So those who did all three are just 2. So that's how it is done. The moment you have that figure, everything becomes easy. This next question that could follow immediately, they could ask you, calculate the number of students who offered one subject. One subject would then be those here, and those here, because those are all the people with one subject. So let's quickly do it. It means 11 plus the 2 added to here, 4 plus the 2 added to this, 8 plus 2. So that gives us 29. So 29 students offered single subjects, one subject only. The next question you could be asked could be to find the total number of students who did at least 2 subjects. What that means when you see at least, it means that number 2 is the lowest value. So you're going to add those who did 2 and those who did above 2. So at least 2 subjects will mean this added to this added to this, and then added to the one in there, at least 2. Those who did 2 and those who did above 2. So 6 minus x, 6 minus 2 added to 5 minus 2 added to 3 minus 2 added to this number itself, 2 and 10. So 10 students did at least 2 clubs. We are members of at least 2 clubs. So that is it for calculations on three-way Venn diagram. Now let's go into the notations of the different compartments in a three-way Venn diagram. So here with me is a typical three-way Venn diagram, and each compartment has been labeled. The usual A only is given the symbol A, B only for B, C only for C, A and C only D, A and B only E, B and C only F. Okay, so let's see. Let's start with A only. If you remember what we did when we were in the two-way Venn diagram, to get A only, we literally just did A intersecting the complement of the rest. So it was A intersect B complement. Now if you observe, there are 2 subsets, there are 2 sets that do not have business with it. So that means it's going to now be A intersecting the complement of B and C. Nice and simple. So this simply becomes A intersect B and C complement. That's what I mean by the complement of B and C. Or some people will actually put it this way. They will say A intersecting B complement and also intersecting C complement. It's the same thing. Second, B only. You can guess. So A and C are excluded. So that could mean B intersecting both A and C complement. If you don't want to put it that way, you can say it is B intersecting the complement of A and the complement of C, and intersecting the complement of C. But if I wanted to say 2 of them combined, I use union. But if I'm intersecting them separately, I use intersect. C only, you can already guess. What do we call it? We'll call it C intersecting both A and B complement. So this is C intersecting A union B complement. That means A and B combined, they are complement. Or if I want to go one by one, it means C intersecting A complement and also intersecting B complement. Now we are done. We've done three major compartments. Now let's start going into the A and B only, A and C only, A and D only. It's also very easy. If you check, let's start with this. So this one, it has A and C, that's A intersects C, but it excluded B. So very simple. So it looks like what we have is A intersects C, but intersecting B complement. That means we are excluding B complement from it. The E, where is E? That's intersect between A and B, but excluding C. So it means A intersect B, intersecting C complement. Nice. The F. The region F is the intersect between B and C, but excluding A, because this G was coming from the A box. So excluding A. That becomes what? B intersects C, intersecting who? The complement of A. Outside A. A is out of it. Now we come to all three. That's the easiest one, is it not? So G becomes what? Both A intersect B intersect C. And lastly, this one that does not have any of them, it means A, B, and C, their complement is what this is. The complement of A, B, and C. So A doesn't have it, B doesn't have it, C doesn't have it. So our H becomes both A union B union C combined, their complement. If you don't want to put it that way, you can say or both A complement intersect B complement intersect C complement. So that is that on the various notations for each compartment of a Venn diagram. Now, you will not be asked, in some cases, they will not just ask you to find A only. What if they had asked you to find this region and this region combined? You know, like they give you this, a combination of two compartments that you've learned. It's simple. It means the first compartment union the second compartment. So it's important you already know each compartment. So now when they are joining, you just use union to do your job. Easy peasy. So that wraps up our calculations on Venn diagrams. At this juncture, we are going to solve a few miscellaneous examples which were forwarded to my inbox specifically for it to be treated in this video. So let's get right into a few of them. We are done. Okay, here is our first example. For those who have the book mentioned, it's in number 2 of exercise 1. So A is written as an equation. So we have to solve that equation, and then the values of x becomes the elements of the set. So being a quadratic, I use my factorization method and split the 5x into 2 factors, which is 6 and minus 1, such that they multiply to give me the -6 and add to give me 5. So you're not new to quadratic, so solve a quadratic equation. The two values of x are -1/3 and -2. As it always goes, you write the lower one first before the higher one in hierarchical order. So that's the easy one. Example number 2. That one is coming from the number 9 of exercise 1 also. It says that another expression was given to us for the set A, and that's a cubic equation. I mean, for those who studied polynomials in their secondary school, this will be way easier for you. They said we should show that that element will provide 1, -1, and -2 as the elements of A. And if we now know, we should also write it in tabular form. Well, for those who have solved polynomials, you know that we have three methods of actually finding the roots of the equation. One is the one called trial by error. The second is the one called remainder theorem. You use remainder theorem to get one factor and then use that factor to divide the polynomial to get the rest. But no need for the long story. We will use trial by error throughout since they have already suggested three values for us. So to show that those three values are truly elements of x, we will now try inserting x as each of those values and see whether the equation will come out as 0. So that's why we say using trial by error method for solving polynomials, we'll now first start trying x equal to 1. The polynomial becomes, anywhere there was x in the equation, we put 1. And as you can see, it truly comes out as 0. Therefore, x is a root, otherwise an element. You also try the second one they gave to you, trying x equal to -1. When you insert x as -1 in each of them again, everything still comes out as 0. That means that x as -1 is truly a root of the equation. And then again, we try x equal to -2 in similar fashion, and once more, that also came out as an answer in the equation. Now you can summarize by saying, therefore, the roots of the polynomial are 1, -1, and -2, which means that the elements in A are, when written in hierarchy in ascending order, -2, -1, and 1. Over to the third example.